Alright guys, welcome to this page of the notes, and what we're going to do here is one of our objectives was talking about rigid versus non-rigid transformations and kind of being able to use those to describe what's happening. So let's go ahead and talk about that to sort of help us answer our essential question, right? One of the things you need to be able to do to answer that question well. So here we go. First, rigid motions. Let me highlight it for you because it's really kind of important. We're talking about the difference between rigid and non-rigid. So a rigid motion, also what's known as isometry, is a translation that changes the position of a figure without changing the size or the shape. We've seen that before in the descriptions that we have written, and in fact, you should recognize these here, right? Look at a couple, you've seen these before. We've written a translation as a description of what's happening, a translation, a change in position in previous problems. We've also done reflection a couple of times, right? So you have seen both of these, the translation and the reflection. And just go back and look at the problems that we've already done. You'll notice that the description was, this was a translation, we changed the position. This was a reflection, right? A mirror image. And in all of those problems, the description was the pre-image to the image, same size, same shape, right? So here's the idea. Translations and reflections are rigid motions, meaning a rigid motion will not change the size or the shape of the object or the figure. All right, they're rigid motions. Doesn't change the size, doesn't change the shape. And we've looked at both of those in previous problems, right? Go back and take a look if you've forgotten. We've seen those. The one we haven't seen yet is a rotation, right? So you can probably guess what's coming, all right? But rotation is also a rigid motion. Does not change the size, does not change the shape of the figure, right? A rigid motion versus a non-rigid motion, which is a transformation that will stretch or compress, what we call a dilation, right? In fact, I've even got it written right here. And guys, we saw that. We saw that in a previous problem. We did one where the size of the triangle, in fact, the shape of the triangle changed. We said it was a dilation because it got bigger. And in fact, in our example problem, the triangle got bigger. It could certainly get smaller as well, a stretch or a compression. But it changed the size and the shape of the figure. That is a non-rigid motion. A non-rigid motion will change the size or the shape of a figure. And that's going to be a dilation, which we've already seen. So we've seen that one as well, right? So of the four kinds of motions, a translation, a rotation, a reflection, and a dilation, we've already seen three of the four. Guess what's coming next? So here we go. Let's try one. Here's what I want you guys to do. You're going to, right here, given the coordinates of the pre-image and the image, I want you to graph both of them. Then you're going to go ahead and write the rule that describes the translation, okay? And determine if it is a rigid or a non-rigid motion. Fantastic, here we go. My image, red. My pre-image, yep. Oh, hold up, whoa, that got crazy. Okay, pre-image in red, image in green. Let's do this thing. Positive 1 up to 1, 2. That is the point A. 4, 2. 1, 2, 3, 4, 2. That is going to be B. 3 minus 2. 1, 2, 3 minus 2. That's going to be C. Boom. Pre-image. Image. Here we go. Negative 2, 1. 1, 2, 1. That is A prime. Negative 2, 4. Negative 2, 1, 2, 3, 4. So there's A prime. That's B prime. C prime, 2, 3. 2, 2, 3. Oh, sorry, I'm kind of drawing on A there, but I think you can see. Boom, right there. All right, so here we go. Let's describe this thing. My triangle, A, B, C, yeah, A, B, C, pre-image. My image, A prime, B prime, C prime. Okay, what has happened here? How have we transformed, right? What is the transformation that we have done to our pre-image to get my image. Okay, this one looks a little bit different, okay? You could say, well, it looks like it has changed position. And I agree with you, but it's more than just a change in position, because please notice the orientation has changed. If it were just a change in position, right, you would still have A prime and B prime up here and maybe C prime down here, or we could have shifted it over here, right? It would maintain that same orientation where A and B are above and C is below, but that's not what's happened here. It's almost like you've taken that guy, changed its position, but moved it from being a vertical triangle to maybe now like a horizontal triangle. You kind of see how its orientation has changed a little bit. Guys, this is exactly what we would call a rotation. I told you it was coming. There we go, rotation. Here's what you got. Here's what I want you to think of this as. If this were, like a little spinner, right? Sometimes when you play a board game, there's a spinner that lets you know, or it's playing Twister, where you put your right hand, where you put your left hand, stuff like that. Or sometimes when you play the game of life, you do the spinner to tell you how many spaces to move, right? Imagine, right, that there's a little spinner right here at the origin, right there. There's my spinner, right? And you're gonna go ahead and give that thing, you're just gonna grab onto it, right? And you're gonna give it a little spin, right? You're gonna rotate this thing and see how that guy, as you rotate it, would come up and right into that spot. A rotation, right? It's a rotation. So that's exactly what we've got here. We have ourselves a rotation. Have a rotation, same size, same shape. And we know from above, a rotation is a rigid motion. Which is the question they wanted us to answer. It's a rigid motion. Same size, same shape. This one was a rotation. And now, the example problems we've done, you've seen all four. A translation, a reflection, a rotation, and previously we saw a dilation. Let's keep going. Let's try a few more together and see what we can come up with. So I've got a couple more here for you. Oh, sorry, those are really tiny. Let's blow those up a little bit. Ow. Boom, there we go. Same thing. Graph them both. See if we can figure out what's going on here. Here we go. Negative 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's going to be D. Let's see. 2, 4. That's going to be E. Negative 4, 1. Negative 4, positive 1 right there. That is going to be F. Fantastic. There we go. The triangle DEF or FED or EFD, whatever. There's lots of different ways to name that. We'll talk about that more when we get to triangles. My image, 4. 1, 2, 3, 4. Right there. So that's D prime. E prime, negative 2. 1, 2 is right there. That's E prime. F, 4, negative 1. That's right there. That got weird on me. Hopefully you guys can see the green. Okay, what has happened here? Please be careful. Please be careful. You might be tempted, sort of your knee-jerk reaction would be to go, oh, hey, look at that. You just put that guy right there, and you give her a little spin, right? You take that guy, it just gets, right, oh, hang on a second. That doesn't look right? That if I were going to reflect this guy across that x-axis by just giving a little spin, right? That would come down here, and that would mean that DF should be here and E should be over here somewhere. That's not what I have. Okay, so my initial reaction was, oh, I have a reflection, but then I think about it for a second and I go, no, that's not what I've got. That's not it. That's not it. So then I think about it for a little bit longer, right? Because we encourage thinking. You should be thinking about this. And you go, okay, well, hang on a second. What if I did this, right? What if this were one of those little spinners in one of those board games I'm playing on, family game night on Friday night, and I give this sucker a little spin. I take this guy and I just, and this guy just rotates right around down into this position if you just give that guy a little spin, right? So again, for the second time in a row, what we see here is that we have a rotation. This is a rotation, not a reflection. Not a reflection. This is a rotation. We already said in the previous one, a rotation. Same size. Same shape. This is a rigid motion. We've answered our question. Boom. Next. Here we go. Let's go ahead and get my pre-image. -3. 1, 2, 3, 4. 1, 2, 3, 4. Right there. There's S. T. 2, 4. Wait. Yeah, positive 2, 4. Holy jeez. -2, 0. Yeah. Right there. That's you. Boom. Man, we really like triangles. We have a lot of triangles. That's right. Triangles are cool. Triangles are cool. S prime, T prime, and U prime. S prime, T prime, and U prime. Here we go. -2, 2. 1, 2, 1, 2. Ooh, look at that. So here is, there's S prime, T prime. T prime is now right there. U prime, -1, -2. That's U prime. Connect the dots. Okay, what do we have here? What do we have here? Well, hopefully pretty quickly after the example problems we've already done, you take a look at this and you go, I know this one. This is a change in position. You're simply taking that guy, right? And you've moved it to the right 1, right? Take an S, gone over 1 and down 2. T, over 1, down 2. U, over 1, down 2. A change in position, what we call a translation. Which is also a rigid motion. Same size, same shape. Translation, change in position, right? Fantastic. Look at you guys go. Hey, I think I got 2 more for you. Just burn through these super, super quick and we'll see what we've got. Here's what we've got. I have given you coordinates pre-image in the image, describe the transformation, determine if it's rigid or non-rigid. Fantastic, we got this. 4, 1. That's going to be J. 4, nope, sorry. -2, -1, -2, -1, that's going to be K. 0, -3. Right there, that is going to be L. I like it. There, like I said. We seem to be all about the triangles today. Hey, let's find that image. 4, 3. 1, 2, 3, 4. 1, 2, 3. J prime. -2, -3. 1, 2, 3. There is K prime. L, 0, -9. L prime. There to there. Okay, yeah, awesome. But please, right? It is not the same size. It is not the same shape. So right away, red flag, hey, you've got yourself a dilation. I have expanded, stretched this figure, stretched it out, which we know a dilation is not a rigid motion. The size and the shape have been changed. So this is a non-rigid motion. Dilation. Got another one for you. Last one. Hopefully what you're doing, right, you've already tried these on your own, you're just coming back, check to make sure you get the same thing I get, that's awesome. Negative 2, 2. Welcome back. Hey, how you doing? Still here, still doing math. 4, 0, 1, 2, 3, 4. That's going to be n. Negative 2, negative 2. That's going to be p. Great. Pre-image. Image. M prime. 8, 0. N prime. Negative 4. Negative 1. P prime. Boom. Man, I did a good job on that one. For freehanding, that's pretty impressive. So there we go. I've got my pre-image in red. I have my image after the transformation in green. What do we see? Different size, different shape. Red flag, right? It's going off. Hey, that's a dilation. And as we said before, if the size is not preserved and the shape is not preserved, if those are changed, you have a non-rigid motion. Hey guys, great work. Thank you so much for joining me for this set of videos. Hopefully at this point you are very comfortable with different ways of describing a transformation and both plotting the pre-image and the image as well as describing the type of transformation and a correlation. What are the similarities? What are the differences now between the pre-image and the image? All of that going back to help us answer that essential question, right? Thank you so much for joining me. I'll see you guys next time.